Hello, so today is going to be the first of videos of making this little keychain knife here that I designed. So first we're going to start working on the back part of it, or I think I've got it named the frame or the scale of the knife. So this is going to be at a 6ALV4 titanium, and we've got to make a fixture to machine it. So I'll show you what I got going on here. So this is the little fixture that I came up with for holding it. So first off, I'm going to drill these holes and stuff, so those are all referenced, and get the top of this flat, and then flip the scale over onto this fixture here. And then it uses, let's see if I can turn on, it uses these screws, which go in like that. They're not completely modeled right there, but you get the point. And then this tapered piece, which you can see interferes just a little bit, which means that there should be some gap between it and the bottom of this, so that it references itself and grips down on there good. So we're going to be machining the bottom part here then. Okay, so here's going to be the plan of attack for machining this. So first off, we're going to do some center drilling, center drill those two holes, and then peck them out. After that, we're going to do adaptive clearing at 10,000 RPM, 100 thou, step over 50 inches a minute to rough it all out there, and then no axial stock to leave, but 10 thou radial stock to leave. And then for the last one, we're just going to do these two outside contours here, and we're going to have in-machine tool compensation and start a little bit big on that, and then work it down into the correct size so I can nail that right on the exact width that it should be, which is 200 thousandths, and then just put a little chamfer on those edges so I don't have to do any deburring work. And yeah, so let's get over to the machine. Okay, so what I've done here is made this a little bit oversized, and now we're going to measure it with the micrometer and see where it's at, and then start out a little bit big for doing the contours, and then tweak it in until it's just right at 200. So right now it's at 220 thousandths and 2/10. So we're going to start it off, and we should on the first pass make it about 2/1000ths over what we would like it to be, and then tweak it in. Okay, so we're about at 200/1000ths and 2/1000ths and like 5/10ths. So what we're going to do is we're going to reduce the size of the tool by half of that, and then we should see this come right into the right diameter. Okay, and now we are dead on, within half a tenth almost. So you can be pretty dang accurate with that technique, even with a machine that's not supposed to hold terribly tight repeatability ratings. If you're doing something very simple like this, you can just tweak it right in and just perfectly nail the dimension you got to do. So here's the finished part. Turned out quite nice. Very, very high RA on this bottom here. I can tell just from feeling it. I know it looks a little messy, but you can see how shiny it is. Those chamfers came out super, super nice. No burrs to be heard of. Now we just got to tap that hole right there. Okay, we got an M4.7 tap here. We're just going to tap these two little holes. Now we've got it all finished up here, and I just thought I'd do a quick little indicating test on it, just to make sure that it's actually flat and parallel to this bottom surface, so that anytime I use the fixture again, it's gonna, be parallel to this top surface and work right. You can see the surface variation. So it does appear that it does move about 3 or so tenths this way. And that could even be due to this being unclean. That's good enough for me. Yeah, about 3 or 4 tenths of total warpedness to it compared to the granite block we got here, but I'd say that's pretty dang good. So there's this part of the fixture done, and now we've got to make the clamp for the top of it. So now we're making this piece here on top. So got a pretty simple operation. Just drill clearance hole for the 4mm 0.7, and then just a little bit of adaptive clearing around the edges there. So here's the piece directly off the machine. Got a little bit of a burr there. There's a little bit of it that it looks like it didn't focus. A little bit of it there, you can see that it didn't mill off completely. It's not bad. We can take that off with some sandpaper here in just a second. Alrighty, so here's the final product, all finished and done. Turned out quite nicely. Here's that little piece. Give you a close-up here real quick. Finished up that little bit of sanding, and quite a nice little piece. The only little whoop I can kind of find is the lead in, lead out right there for the chamfer tool, and I think it's mostly a finish look than it is a deviation in the surface. I can't seem to feel it with my finger, so but there's that. And then so this is gonna go on here like this. Then I'll have the two bolts here, and then that big taper on there should be enough to hold down the aluminum just so I can cut the outside contours here along this edge. This is inset, I don't know, 30 or so thou from what it actually should be, so the end mill shouldn't be touching anything. And it'll have this nice smooth surface to reference off, but there you can see clamping angle. And so in actuality, once it's done, if I machine the chamfer correctly, should be up in the air like this and mating up against that bit of chamfer there on each side, and that should give us some self-centering clamping force. Also right there you can see another lead in, lead out line. I guess we'll see if this works. There's a possibility it doesn't have enough clamping force, and I might have to switch to just kind of making a bigger plate that goes on top to smush it down if this doesn't have enough rigidity. But I think these 2 points in that slot in the frame should be good enough. But next video will be machining up that titanium frame for this. Thanks for watching.